All right, this is going to be video number 7 for polynomials, and we're going to do factoring difference of two squares. You need to think about what the word difference means here. It's a minus of two perfect squares. Now, you got to remember that this is minus, and what is a perfect square? So you need to think about what a perfect square is. So perfect squares are going to be numbers that can multiply by itself to give you a number. So for example, 4 is a perfect square. 2 times 2 is 4. Also, the very first perfect square should be 1, because 1 times 1 is 1. All right, so 3 times 3 is 9, so that's a perfect square. And then you're just going to keep going up through there. So 16, 25, 36, 49, and so on. Those are all going to be perfect squares for you. Because 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, and 7 times 7, and so on. All right, now with your variables, you are looking for variables that are x squared, x to the 4th, x to the 6th, and x to the 8th, and so on. You're looking for even exponents. Even exponents, because those are multiples of 2, because I can take x squared and break it apart and do x times x. X to the 4th would be x squared times x squared. X to the 6th would be x times, or x to the 3rd times x to the 3rd. Remember, when you are multiplying, you're going to actually add exponents. So that's why they're going to be like x to the 3rd times x to the 3rd. All right, so I'm going to show you how to factor these perfect squares. So we're going to start with our examples here. And we're going to do example 1 here, which is going to be x squared minus 25. All right, so you need to know some basic things here. Every single parentheses that we have here, think back to when we did multiplying last week with special cases. Multiplying with special cases, I'm especially thinking about example number 1. Every parentheses is going to have something. You're going to have something like this. You're going to have some variable plus a number, a variable minus a number. So you're going to have a minus and a plus in each one of these. And think about that. How do you get a negative 25? Positive times a negative. So on every problem, you're going to start out like that. Now, what times what gives you x squared? And I'm hoping that you're thinking x times x. So x times x is going to be our first term right there, because these are all going to be perfect squares. What times what gives you negative 25? So I'm hoping you're thinking 5 and negative 5. So you need a positive 5. And we're going to, that minus sign right there takes care of that negative 5 for us. So this right here is factored for us. If we FOILed this out like we did last week, then you should get the same answer up here. And that always will work for us. So let's do another example here. Let's do 16x squared minus 49. And if you notice on this one, 16 is a perfect square, 49 is a perfect square. So both parentheses, we're going to start out with a plus and a minus. Now I can switch these around and put the minus sign first and the plus sign first, or minus sign first and plus sign second. That doesn't make a difference. What times what gives you 16? So I'm hoping you're thinking 4, because you're looking for the same number. And then x squared would be x times x. So you're putting a 4x in both parentheses. Now, what times what gives you 49? And it's the same number, so a 7 and a negative 7. And that minus sign takes care of that negative for you. So right there is your factored form. Let's try number 3 here. Let's do 81 minus 25y squared. I know that you're used to putting the variable first, but we cannot switch this around because of where that minus sign is located right there. So let's start with our both sets of parentheses here, and we're going to have a plus and a minus in each parentheses. Now, what times what gives you 81? This is the same number, so 9 times 9. And you got 25y squared. What times what gives you 25? So let's go with a 5. And since that's a y squared, we're going to do a y. And we're going to have another 5y. Notice they're the same exact thing in each parentheses except for the sign has changed. Let's do a fourth one here, and let's put x squared minus 36y squared. This time we have two variables here. With these two variables here, you still need to think about doing the exact same thing. What times what gives you x squared? So let's go with x times x. What times what gives you 36? Let's go with 6 and 6 because they have to be the same number. And then you have y squared, which would just be y and y. So x plus 6y and x minus 6y. All right, let's do another example. And let's do 100 x squared plus 121. Let's start out with both parentheses here, plus and a minus. What gives you 100x squared? Let's go with 10x and 10x. Now what gives you 121? That would be 11, but notice this right here is a plus sign. The only way to get a positive 121 is 11 times 11 or negative 11 times negative 11. Both of those are the same sign. And with perfect difference of perfect squares, you have to have one parentheses positive and one parentheses negative. Because this does not fit, this is called prime. That means prime means it cannot be factored. And I want to show you one more example here. Let's do 9x squared minus 8y squared. You may think about just go automatically to your parentheses here, and you know 9x squared would be 3x and 3x. But notice the 8 is not a perfect square. It is not one of these perfect squares that we have listed up here. There is nothing times itself that will give you 8. So that means this problem cannot be factored, which also means it is prime. So if you ever have two terms like we do right here with a plus sign in the middle, it cannot be factored. It does not even have a GCF. And this right here is not a perfect square. They have no GCF or anything in common, so it is prime.